why are we here? I mean, really, why is anything here at all? According to our best theories, the Big Bang should have created a universe filled with, well, nothing but light. But instead, here we are. We've got galaxies, planets, you, me. So yeah, we're going to dive into this. Today, we're opening the case file on one of the biggest cosmic mysteries out there, the universe's missing antimatter. So, here's how we're going to crack this case. First, we'll examine the scene of the crime, right back at the very first moments of the universe. Then, we're going to question the prime suspect and see why its alibi is totally airtight. After that, things get interesting. We'll explore a pretty radical new theory that the universe itself is tilted, and we'll see how that one clue could solve a bunch of cosmic mysteries at once. And finally, we'll look for the actual fingerprints it might have left behind on the cosmos. Okay, let's get to it. We are going back 13.8 billion years, right to the instant after the Big Bang, to investigate the fundamental glitch, the tiny error that literally created everything. And really, this is the question at the heart of it all. It sounds kind of philosophical, right? But for physicists, it's a huge practical problem with the universe's origin story. The evidence we see all around us today, it just doesn't line up with the theory. So, this is the massive disconnect we're talking about. See, the laws of physics are supposed to be almost perfectly symmetrical. For every particle of matter created, an equal particle of antimatter should pop into existence. And then, well, they should have immediately found each other, annihilated in a massive flash of energy, and left behind a vast, empty universe filled with nothing but light. But, obviously, that's not what happened. Something tipped the scales. And get this, the margin was razor thin. We're talking for every 1 billion antimatter particles, the universe somehow managed to cook up 1,000,000,001 matter particles. That single, lonely leftover particle, repeated over and over again across the cosmos, is the ancestor of every single atom in existence today. It's the ultimate cosmic rounding error. In the world of cosmology, this whole case has an official name. It's called baryogenesis, and it is the central puzzle we have to solve if we want to understand why our universe looks the way it does. Now, for decades, physicists had a prime suspect for this cosmic crime, an idea that comes straight from the standard model of particle physics. But as we're about to see, its alibi is, well, it's rock solid. Our suspect is called CP violation. And it's a real thing. We've measured it. It's a phenomenon where some of the universe's fundamental forces treat matter and antimatter just a little bit differently. It's a known asymmetry, right? A tiny crack in that perfect mirror between the two. And for a long, long time, this was our best and only lead. But here's the kicker. When you actually do the math, the CP violation that we know about in the standard model, it's about 10 billion times too weak to explain all the matter we see today. 10 billion. That's not just a little off. It means our prime suspect wasn't even in the right zip code when the crime happened. The case went completely cold. This is where our investigation just flips on its head, all thanks to this one really powerful analogy. It suggests that maybe we've been looking in the wrong place all along. Blaming a particle or a force is like trying to figure out why a room is tilted by just studying the furniture. The problem isn't the furniture, it's that the floor itself is crooked. So this is a huge shift in thinking, right? The old theories, they were all looking for a dynamic cause, the furniture, something to do with how particles interact. But this new theory proposes a geometric cause, the floor, arguing that the asymmetry isn't something that happens in space, it's a fundamental built-in property of space, the vacuum of the universe itself. And that brings us to this absolutely mind-bending idea. What if the very fabric of reality is biased? What if the universe itself has a preferred direction, a fundamental tilt built right into it? Okay, the fancy name for this is chirality, which really just means handedness. Like your hands. They're mirror images, but they're not identical. You can't perfectly overlay them. This theory says that spacetime itself has a handedness, a built-in preference for one geometric orientation over its mirror image, like a left-handed glove versus a right-handed one. So how could this even happen? Well, the idea is that as the super hot, perfectly symmetrical early universe started to cool, it went through a phase change. It crystallized, kind of like how water freezes into ice. And just like water has to pick an orientation to form a crystal lattice, the universe had to break its perfect symmetry and freeze into a shape with a specific handedness. It basically had to choose a side. Now, here's the really compelling part. A great theory doesn't just solve the one problem you're looking at. If this geometric flaw is real, it should solve other mysteries too. We should be able to see its echoes scattered all across the cosmos. And wouldn't you know it, we have some other pretty big unsolved cases. This connects three of the biggest head-scratchers in physics. First, our matter problem. Second, a very strange 7% temperature difference we see between the two hemispheres of the cosmic microwave background, the afterglow of the Big Bang. And third, the bizarre fact that only left-handed neutrinos seem to interact with other particles. I mean, think about that. Three of the biggest puzzles out there, all potentially explained by this one single idea. They might not be separate problems at all, but just different symptoms of the same root cause, a handed universe. But hold on, there's an obvious question here, right? How can a huge 7% asymmetry in the background radiation be connected to a teeny tiny 1 in a billion asymmetry in matter? The numbers seem totally out of whack. The answer is this concept called chiral filtration. The key is that the relationship isn't direct, it's exponential. Imagine you have a sieve that's tilted just a tiny bit. If you try to push a specific shape through it, most of the time it just won't fit. Well, that 7% geometric tilt in the universe acts like that sieve. It makes it exponentially harder for the wrong-handed antimatter to exist. It's so incredibly effective that only a tiny, tiny fraction, about 1 in a billion, manages to leak or tunnel through the filter. Okay, so a good theory doesn't just explain old mysteries, it has to make new predictions that we can actually go out and test. So for our final act, let's look for the fingerprints. What clues could this cosmic handedness have left on the universe that we can actually find? And this theory gives us three very concrete, observable things to look for. If the universe really is handed, we should be able to see its fingerprints on everything, from the fundamental laws of physics all the way up to the spin of entire galaxies. So let's quickly break those down. First, we can look for variations in physics across the sky. If the universe has a preferred direction, then maybe a fundamental constant like CP violation isn't actually constant. It might be slightly different depending on which direction we look. Second, the theory predicts the mass of a hypothetical right-handed neutrino. If we ever find one, its mass shouldn't be random. It should be a specific predicted value. And third, and this is just wild, we could look at how galaxies spin. If the vacuum itself has a grain, it might have subtly influenced how galaxies formed, creating a tiny but measurable preference for them to spin one way over the other, across the entire universe. When you put it all together, this theory offers a really profound new perspective. Our existence might not be because of some weird particle interaction or some random fluke. It could be a direct result of a fundamental imperfection in the geometry of the universe itself. We are here because the vacuum of spacetime isn't perfectly smooth. It has a grain. And that leaves us with this one final lingering question. If this theory is right, it means everything we see, from the tiniest particles to the largest superclusters of galaxies, carries the signature of a choice the universe made in its very first moments. It shows a direction. It picked a side. The question we now have to go out and answer is, which one?